So we're ready to create the polygon definition that we are eventually going to use to create our floor. Let's start that. We'll call it big long shape definition. And we basically just call the new constructor. And now we actually need to define the shape. Like you're probably expecting, we're going to define this polygon through a series of points. There are a couple of rules that we do need to follow, however. And yes, we're back in the PowerPoint. So first of all, you need to define a convex polygon. So if you want to create a concave polygon, like say this fun arrow here, basically what you would do is break it up. We'd break it up into two convex shapes, the rectangle and the triangle. In our case, we're creating a floor, which is a nice long rectangle. We don't need to deal with this. Points are defined clockwise. I think if you actually read the wiki, it tells you points are defined counterclockwise, but that may change depending on whether your camera is in the positive or negative z-axis. As it turns out, for Flash, points are defined clockwise. And how do you define points? Good question. It turns out within our B2 polygon definition, we basically have two variables that are already created for us. There's a vertex count variable and a B2 vertices array. Now this array is basically by default created with 8 points in it. All of these points are basically not really points, they're B2 vec2s that are all set by default to 0, 0. Now basically what would happen is if say I were to define a triangle, I would set my vertex count to be 3, and then I would go into my B2 vertices array and change those first 3 entries into, some real points that I would actually want to use. And then, basically Box2D would know, okay, let's take a look at points 0, 1, and 2 in this array because those are the ones I intended to use because vertex count is set to 3. I don't know exactly why Box2D does this instead of just creating a dynamic, array that you would push points onto as you want to define them. I'm guessing it's some sort of performance optimization or maybe just a way that worked a whole lot better in C++ than it does in Flash. I think it's a little weird, but you kind of get used to it. So now that we kind of understand what's going on here, I think we've probably got a pretty good idea as to how we would actually want to create our points. First thing we probably want to do is set our vertex count to 4. Because basically, we want to create a big rectangle that is going to take up the floor of our world. And now, basically, I'm going to cast So I'm basically taking the first entry in the vertices array that's included in my big long shape def. I am casting it as a B2 vec2 because I happen to know that's what it is, which then allows me to use the set function to set the point. Now, let's see. I guess we want to create a rectangle that maybe is 550 pixels wide, since that's going to be the width of my stage, and let's say 10 pixels high. So basically, I'm going to set it the way I think most of us probably define rectangles in Flash, which is to have 0, 0 be the upper left of the rectangle, and then we'll go from there. So this first point here I'm going to set to 0, 0, and just because it's a good idea to get into the habit of this, I'm going to divide this by that ratio number that we defined earlier. Remember, I'm going to be, even though mentally I'm thinking of this rectangle in terms of pixels, as far as Box2D is concerned, it wants it in terms of meters. And so we'll keep going. So now I'm going to set the upper right corner. And now I'm going to cut and paste because I'm getting tired of doing this typing. So our third vertice will be at 550, 10. And our last vertice will be at 0, 10. Note that I don't need to kind of close this loop. I don't need to find another vertex that's at 0, 0. Box2D will know to do that by itself. Now, once we've done that, there are a few other things we're going to set within the shape definition, things related to the physical properties of this box that we're basically creating. Those would be friction. This is usually a number between 0 and 1. I actually don't know exactly how this converts to real-world physical units, but I know that usually if you set things to 0, 0.1, something like that, you'll get a lot of sliding. If you set it to 1, things don't slide much. Let's go with 0.5. Don't know why, I'm just kind of picking that number. Restitution is another thing we're going to set. That basically kind of determines how bouncy this thing is. I'm sure there's a better description for it in terms of the physics world, but bouncy is pretty good. If I were to make this equal 1, it would be, a super ball. If I made it 0, it would be, I don't know, like lead. Let's go with 0.4 something, 0.3, nothing too bouncy. Remember, this is the floor, which is, well, I suppose it can be any material we want, but I usually don't think of floors as being especially bouncy. And then the last thing we're going to set, and actually I suppose we don't need to set this because I think by default it's set to 0, but I like setting it explicitly, is the density. Density is typically a measure of, well, an object's density. I think if you set it to 1, that's about the density of water. Less would be for wood, greater would be for metals. Here I'm setting it to 0.0, and that this doesn't mean that I'm going to be creating some cloud-like object that has no density at all. This is sort of a special value that tells Box2D that this object is kind of permanent and fixed in space. Obviously, you don't run into this a lot in the real world, but in video games where you've got platforms that you want to make sure your character can jump on and land and don't really want to have to worry about somehow supporting this structure that you just want your guy to jump on and land, you'll be setting density to be 0 for any object that you want to be stuck in space. As it turns out, our floor is a very good object to stick in space, and so that's why we're doing it here. Alright, that was a long time creating the shape definition. The other 3 will go faster, but just to prevent my file size from getting too large, we'll put that into the next lesson.